So just a quick video here going over the worksheet, the first scatter plot one we had. I know these problems are a little bit difficult and it's a bit more of an abstract concept, so I'm not expecting everybody to have these perfect right away. So follow along with your paper and go through and see if I can answer some of the questions you had on this one. Here we go. So we're going to go through the scatterplot worksheet from a Wednesday, 12/16. Talk about the answers on this one. So I know it's going to take us a little bit to get good and comfortable with these. So if you are having trouble with this one, don't worry about it. We're going to go through this together, and we're going to do a few more of these worksheets. So by the end of this week or middle of next week before Christmas break starts, hopefully you'll be comfortable with these. So this very first one is said, the scatterplot shows the number of CDs in millions that were sold from 1999 to 2005. Right, and you can see that on the graph here. We had 1999 all the way up to 2005, and then here's our plots on there. All they asked us for this one was if this trend continued. Right, so you can see there definitely is a negative trend in the data here. If that continues, about how many CDs do we think would be sold in 2006? Right, so 2006 would be on the end here. So basically what they're asking you to do is just, if you wanted to draw the line of best fit in, you can. But you can kind of just picture this one too. All right, but that's the idea. If this same trend continued, where do we think it would be? I can see, I'm guessing most of you are probably right around the same spot, right around 650. All right, so if that same trend continues, it'd be a good educated guess to say in the year 2006 about 650 million CDs would be sold. Number 2 was talking about family. So it said the table shows the predicted annual cost for a middle income family to raise a child from birth until adulthood. All right, so they have the child's age, 3 years old, 6 year olds, all the way up to 15-year-old. And then they have the cost for the year for the family. So for this one, you did have to make the scatter plot first. Right? So it was nice, at least they have it all set up for you. So we have the age on the bottom for our x-axis, the annual cost in thousands there on the side. So graph it, so we'd go over 3, and then again with these, there's going to be a little bit of estimation. So 10,700, we're going to be in between 10 and 11 there. 6 and then 11,700, so same thing, a little bit in between them there. 9 and then 12,600. 12, 15,000. And then 15, 16,700. All right, so just visually looking at that first, definitely a positive correlation going on. You can see the trend is rising. Then they ask us just to do that, really. You don't have to do anything else for this one. It just says, describe what relationship exists. So we already said positive. All right. What does that mean with our data? Well, the older you get, the more you're going to cost, right? All right, so the older a child gets, the more expensive they are for the family. Number 3. Now this one didn't have any data at all attached to it. They just gave you an X and Y chart, and they said make the scatter plot and then draw the line of best fit. And then this one you had to go full pull, and they wanted you to write the equation of it. All right, so first step is just to plot those ordered pairs. All right, so have it up on the screen here. So we had -2, 2. So we left 2 up 2. Remember, when you're plotting the ordered pairs, the X value goes first. So -2, 3 is next. So I'd go left 2, up 3. -1, 2. 0, 1, 1, 0, 1, 1, 1, -1, 2, -1, 2, -2, and 3, -2. All right, so making that plot first. This one you can see a negative correlation going on. So now we're going to draw the line in. All right, and this is the part here where I mentioned in a couple of the videos so far your line may not be identical to the line I am about to draw right here. It could be a little different, but as we said, making a joke in the baseball one, they should be in the same ballpark. Once you draw that line, to write the equation, we just need to find the m and the b. So remember, don't make this part more complicated than it has to be. You're literally just going to read them from the graph. The b, where does this line cross the y-axis? Blammo, right there. So my b is 1. The slope, find 2 points that your line went through. Right? Make it as nice as or as close as you can. So I'm going to choose that one and then this one. It doesn't have to be a point that was on your scatter plot, right? You're just looking for any grid spot where the line went through perfect. So I chose these 2. Once you pick your 2, you're just going to count out the slope, rise over run. So I went down 1, so -1, and I ran 1. So -1 over 1, which I could simplify to -1. And then you could write your equation from that. So I would have y equals -1x plus 1 for the equation of my line of best fit. Yours may not have been identical to this, right? I'm assuming just by how close and how strong this relationship was, most of you probably had 1 for your y-intercept, but maybe you didn't have -1 for your slope, or maybe you were a little bit more, a little bit less, but as long as you're in that zone, it's going to be okay. So we could have a little slightly different answers for these when you have that equation for the line of best fit. Number 4 on this side, we had a XY table given to us again. All right, so this one was study hours and then the grade that the student had. So our first spot would be to put it on our graph here. For this one, there wasn't, we didn't have labels yet, so you had to do that on your own. So I'm going to put the hours on the bottom. I'm going to put the grade on the left here. All right, so the hours, we're just going to go 0, 1, 2, 3, 4, 5, 6, 7. The grade, though, sometimes you may need to make some adjustments here. So when you look at their grades, the lowest one they gave you was 60, but then it went all the way up to a 90, and presumably the top of the graph would be 100. So when we're putting our labels on here, you might want to change your scale, what you're counting by. And another thing with this one, this little indentation there, that's allowing you to kind of skip some numbers on your graph. So as I said, the lowest number we had was 60. So rather than start my graph at 0 and count up, I'm going to start the graph at 60 so we don't have so much wasted space. Right, and then I'm going to count by 5. So I'm going to have 65, 70, 75, 80, 85, 90, 95, 100. Right, so right here could have been our first differences in our graphs. You may not have counted like that, and that's okay, as long as what you had fit everything. So making the graph up, so we had over 3 up 84 for the first one. 277. 592. 170. 060. 490. And then 375. All right, so just looking at the data there, again, you can see a positive correlation going on for sure. Next part says to, or just ask what is the equation for the line of best fit. So let's draw that guy in. So I'm going to go with something like that. So we need to find the equation. So that means we need to find our M and our B. So the B is always the easiest. Where does it cross the y-axis? Mine's smack dab at 60. So speaking of differences here, as long as your y-intercept, as long as your B value was, say, between 55 and 65, I would say that's okay, as long as you were somewhere in that spot. My slope, So I'm going to use that point, my y-intercept, and then I'm just going to look for another point that my line went through perfectly. That's close. This one here I whacked pretty good though. So notice that wasn't one of my scatter plot points, but I went through that coordinate perfectly. So the more perfect you go through a coordinate, the better your results are going to be. So that's why I picked that one. So I'm going to count the rise over run between those 2 points. When I'm counting, so I'm going to count my rise first. So I went up 1, 2, 3, 4, 5, 6, 7. So I went up 7 spots, but just a caution on this one. Remember, we adjusted the scale. So I'm counting by 5s over here. So I went up 7, but really that would be 5, 10, 15, 20, 25, 30, 35, since each block is worth 5. All right, so I went up 35, and I went over 1, 2, 3, 4, 5. So my slope is 35 over 5, which I can reduce to 7. So your slope, again, it may not have been that identically, but it should have been probably close to 7. So if you take your two numbers and divide them, you should be around 7 somewhere. So my equation would be y equals 7x plus 60 for part B. Part C said predict the grade for a student who studied for 6 hours. So there's 2 ways you could go about this. Hours are referring to your x values. Okay? So one way I could do it is I could take that 6 and plug it in for x to make a prediction. All right, so 7 times 6 would give me 42. 42 plus 60 would give me 102. So I would predict he would have a grade of around 102. So I would say the student would score around 102% if they studied for 6 hours. Another way you could do it, if your graph goes up enough, which it does, here we go up to 6, is you could look at the line that you drew in. So I could go over to 6 hours and just go up and see where does my line of best fit cross that. Right? And you can see it's pretty close to being almost exactly accurate to what my equation said, which it should be. I'm right around 102 mark there, just above 100. So either way, you could get that result. Part D on this one yet? I almost forgot about that one. Part D said, could this line go on forever? Why or why not? And for this one, I would honestly accept either yes or no, as long as you backed it up with something that was appropriate. Could this line go on forever? Some of you may have said, yes, it's a line. Lines go on forever. I would have accepted that. I think what they were trying to get you to picture here, though, was what was going on with your actual data. So we have hours and the kid's grade. So does it make sense for the line to go on forever when you look back at the data we're given? Probably not, right? There's going to be a finite amount of hours this kid could study, unless he's a robot. And also, generally, the grades top out at 100%. Right? So it's not going to really make sense for this line to go up any higher than where we have it stopped there. So again, as long as you backed up your answer with a reason, I would have accepted either or there. But I think they are trying to get you to say no, because the scenario kind of doesn't need it to go on forever. Number 6 on the back, going to baseball again. So it says the scatter plot shows the average price of a Major League Baseball ticket from 1997 to 2006. For this one, a little different. They give you 2 points, so they pick them out. So they say use the points 2001, 1760 and 2002, 1875 to write the slope-intercept form of the equation. So this one, it's going to kind of go back to exactly what we did with type 3 problems, since they give us those 2 points to use. Right? You could have x1, y1, x2, y2. Plug them into slope formula. All right, so you'd have 18.75 minus 17.6 up top, 2002 minus 2001 on the bottom. So that would give you 1.15 over 1, or 1.15 for your slope. I could plug that in and figure out my B, or I'm going to go ahead and make a approximation here. It looks like that line of best fit is crossing right at 12. Okay. So I'm going to use my B as 12 just from looking at the graph. So my equation would be y equals 1.15x plus 12. The next part says use your equation to tell the price of a ticket in 2009. So our data only goes up to 2006. So 07, 08, 09. We'd be looking for a couple years down the road. So our graph doesn't go that far. So we'll have to result back to this equation. So 2009, the data starts at 1996. All right, so we want to figure out, or 1997 rather, my bad. How many years went by to 2009? Right, so you want to take 2009 and subtract 1997. You should come up with 12 years. So that was 12 years ahead. So 12 is going to be our x. So I'm going to plug the 12 in to my equation. Okay. So 1.15 times 12. So that should give you 13.8 plus 12. And then add them together, 13.8 plus 12. We're talking about money, so I'm going to tack on that 0. So I would say in the year 2009, a baseball ticket would cost around $25.80. Number 6, talking about diseases. So the table shows the number of cases of foodborne botulism in the United States from 2001 to 2005. So this one, they give you the graph. They have it labeled already for you. You just have to draw in the points. For this one, they kind of have these labeled a little wonky. I don't know why. So I'm just going to adjust it. I'm going to do 01, 02, 03, 04, 05. So I'm just going to make it counting by ones on the bottom there. So 2001, we were at 30, I think. Let me double check with the computer. 39. So 2001, we were at 39. So close to 40. 2002, we were at 28. Close to 30. 2003, we were at 20. 2004, we were at 16. And 2005, we were at 18. So then we want to determine what the relationship was. So for this one, that would be a negative correlation. It's going downhill. So that means that each year the number of cases was going down, except for it crawled back up a little bit at the end there. All right, so it's a negative correlation. So the relationship that exists in the data is that the cases are decreasing over time. Drawing a line of fit for a scatter plot. And we're going to write the equation. I'm going to draw this in, and you could kind of I say sometimes you almost ignore those outliers as they call it, like that last point. But I'm going to draw my line in like that, and yours may be a little bit different. My B, where did I cross the y-axis? I was right at 50. And then my M, I'm going to count. So I'm going to find 2 points I went through. That one there I got pretty good. And that one there. So again, both these points weren't part of my scatter plot, but that's okay. We're just using the points that your line went through to count out your slope. So again, watch your scales. So we're counting by tens on the Y here. So I went down 10, 20, 30, 40. And I went over 1, 2, 3, 4, 5. So negative 40 over 5 will reduce to negative 8 for me. Again, your slope and y-intercept may not have been these two numbers, but they just should have been close to it. So my equation for this one will be y equals negative 8x plus 50. And that's it for this one. They didn't ask you to make any predictions. Number 7, going to the zoo. So this one, they had the graph there. They had it labeled for you nicely already, so that makes a big difference. You just had to plot the ordered pairs first. So we have 1247. And then you're doing some guesstimating here. We have 2550, 1540, 820, 3570, 4077, 4161. Then we had 2054. So what relationship, if any, exists? Definitely positive. So as the average went up, so did the maximum age of the longest animal that lived. Right? Drawn in the line of best fit. I'm going to go with something like that. All right. Find our M and B. So I'm going to say my B, I'm a little bit above 10 there. All right, so I'm going to say my B is 12. Slope, I'm going to pick 2 points. So I go with that one I crashed through pretty perfect. And that one up here. And then I'm just... So I'm going to count these out. So remember, watch your scale. So we're counting by tens on our Y here. So this would be 10, 20, 30, 40, 50 for my rise. Counting by fives on the bottom here. So for my run, that would be 5, 10, 15, 20, 25, 30. So 50 over 30 I could reduce to 5 over 3. All right, so that would be 1.6666. So 1.67. Again, your slope did not have to be that exactly, but it should be somewhere close to that. So my equation would be y equals 5/3 x plus 12. This one, there was a part C that said predict for a 33-year, for an average of 33 years. Right? So that would be your x. So in 2 folds here, you could plug in that 33. And work it out. Alright, so that's going to give you 55. So 67 years for a maximum. You could also have looked at your graph. Right? So if I went over 33, blammo, and then followed it up till I hit my line, and you can see again, just as that last one, it's almost perfect. You'll be right around the same thing, right around 65, 67 area. So we're going to continue with a few more of the scatter plot worksheets this week, and we'll do the same system here. I'll post up a video of me going over the worksheet the day after so that you can follow through and make sure you're correct. So that's going to be it. Hopefully you're enjoying the snow and not working too hard digging yourselves out. We'll see you soon.